Good morning, everyone. My name is Angelo, and I'm system engineer at Banca. Today, I am going to guide you through the Cilium Egress Gateway feature and show you how we manage high availability in our on-premise Kubernetes cluster. We will check what happens under the hood, and hopefully we will have time for a small demo and your questions. But first, let me introduce our company. We are a Swiss company, as you know. Switzerland is famous for Alps, chocolate, and banks. And surprise, surprise, we are a bank. Corner started its business in 1952, started offering, it was the first offering Visa card in Switzerland, also the first offering Apple Pay in Switzerland, the second, I suppose, after UK in Europe. And we started with Kubernetes 8 years ago and played with many toys like, for example, Windows Worker Node, another hot topic, Calico, Kyverno, and many other tools. And in the last 18 months, we approached the migration to Cilium. But now, back to our topic. We have our cluster, our control plane, our worker nodes, some pods, and an external resource we want to reach. And without any additional configuration, our pods are able to reach the outside world using the IP address of the node. And this IP address is shared between everything is running on the same node. If our workload is scheduled on 2 different nodes, we will use 2 different IP addresses. And this scenario could be OK for most of us, but we're a bank, and bank are obsessed with encryption, authentication, and firewall rules. So we need to identify the traffic of our pods outside the cluster. For this reason, we can dedicate some nodes that can be called Egress Gateway nodes, are not required, but suggested, and we can configure an additional IP address dedicated to our workload. Next step is to configure a Cilium Egress Gateway policy, and where we can specify a pod selector, a specific node selector for our egress node with the specific IP address. And once configured, the traffic will be forwarded by Cilium from the worker node to the egress node, from the correct egress node to the side world. So as a bank, we can be happy, and we can spend the remaining time of this presentation celebrating our achievement. Or ask what happens if the node 1 fails. OK, you can tell me that I can configure a wider node selector and select 2 nodes, and this could be correct in some way, because Cilium will use this list of nodes in alphabetical order. So if node 1 is up, running, we are happy, and we are able to reach the outside world. But if the node 1 fails, and Cilium tries to use the second node, pods will get stuck trying to contact the outside world. We can manage this floating IP address, for example, with SpaceMaker, or we can use the commercial version of Cilium that supports 2 different IP addresses for the same policy on different nodes. Or you can start an open source project and see what happens. We can go back to our cluster, install a requirement, kubevip, that is needed to manage our floating IP address. We can install our operator, and then we have a kubevip waiting on the Egress Gateway node for something to do. We can create a HA Egress Gateway policy that uses the same syntax of a Cilium Egress Gateway policy, and we can select our workloads. We can add an annotation that will be used by kubevip to use that specific IP address as exit IP address, and select a generic node selector. And kubevip will configure the IP address on a node elected using Kubernetes leader election, and Cilium will use it to as a Egress Gateway node. So the traffic is routed from the worker to the selected node, and from the selected node to the outside world. If the node 1 fails, no problem, because kubevip elects another node as a leader, configure that IP address on that node, and continue to work without issues. And let's check what happened under the hood. We created the HA Egress Gateway policy. And the operator creates 2 additional objects, a service, a dummy service, let me say, a service without a valid backend, with all the annotation and labels provided in the original policy, and initial Cilium Gateway policy. Then kubevip say, okay, I have to implement this service, so bring the IP address specified in the annotation and set the status of the service, implement the service, and notify us that the IP address is running on a specific node using a specific annotation, kubevip vpost. With this information, we update the Cilium Egress Gateway policy, we patch it with the new IP address and the specific node selector. During a failover, kubevip will elect another node, update the annotation, we update the Cilium Egress policy, and we are again happy, but I'm sorry, with PDF we can't show the demo, but we have two screenshots. On the top left, we have a demo pod that's trying to contact the outside world, and the outside world returns our external IP address. On the top right, we see the status of HA Egress Gateway policy with the name of the exit node, the current exit node, and the last time the status has changed, that it could be useful for debug reasons. And the second screen, we can see that, we can't see, but trust me. We reboot node 2, so node 2 goes offline, node 1 takes care of our egress IP address, and the policy is updated, and the test container continues to reach the outside world with some trick that we can see at the end. Okay, conclusions. The operator orchestrate kubevip and Cilium, doesn't replace Cilium, doesn't replace kubevip, doesn't manage IP address. So we use other open source software like kubevip. And during the failover, it's clear for you that existing connection will be dropped, and the failover takes about 2 seconds, 1-2 seconds. So you have to set a connection timeout of 5-10 seconds in order to don't lose the connection, don't lose requests. And finally, every IP address you create generates a list, generates a service, generates an annotation. So if you want to manage, for example, in our case, 1,400 IP address on the same cluster, you have to take care of the list time configured in kubevip, and the query per second limit configured in kubevip, and your API server. Finally, thanks to operator framework, because it's very easy to create an operator with the support, Cilium and KubeCon for this space, and you for your attention. I don't know if there is any question, because I have one. Okay. So why did you use kubevip and not Cilium for the, let me say, dummy service? First of all, thank you for your answer. And to be honest, we tried 3 different services, kubevip, Cilium, and Metal Load Balancer. And we have 2 requirements. Something to observe, to be notified that the IP address has moved from a node to another. And Cilium needs that the IP address is already configured in the IP stack of the node. For the first requirement, kubevip is OK, because notify us via service annotation. Cilium uses a Kubernetes lease, so we can follow it, and no, Metal Load Balancer won't share information with you. Second, we have to configure IP address on the node, and kubevip does it. Cilium uses a L2 ARP announcement, so it works, but generates every time a warning, every time you use the egress policy, and Metal Load Balancer does the same. So for this reason, as you can see, kubevip won the competition, also because it's the only one can hold the trophy. So thank you.